Today we'll begin with our last chapter, chapter 5, sound and Doppler effect. So we'll begin with the sound, and then when we finish with that, we'll move towards the Doppler effect. Now, whenever I use the word sound, the first thing you remember is the sound technology. And when you talk about this word, you can't forget taking the name of the great scientist, which is Alexander Graham Bell. So Alexander Graham Bell is the inventor, or he has shown lot of interest. Okay, so he is the person basically known for his invention of the telephone, revolutionized the communication. Okay, and his interest in sound technology, that's the reason he could form or launch his own Bell telephone company in 1877. Okay, now as you have to define, now after knowing this great scientist name, we have to define sound. What is sound? Basically, sound is a vibration. How it will move? It will propagate. It will propagate as an acoustic wave through a medium. Now what medium? Either you use a medium which is gas or liquid or a solid. Okay, so there is no person in the world, in this world, who has not listened to any sound or music in a day. So every day you come across this sound and music. Fine. So as we enjoy life with seeing things, okay, even with your ears have got the sensation of this vibration of the wave. That's the reason we could recognize the sounds clearly. So basically, sound is a wave that is created by the vibrating objects and propagated through a medium from one end to the other end. Okay, now moment you talk about this, so the next job is the classification. How do you classify them? So I'll write over here classification. So classification, first thing is the audible range or audible wave. Now audible wave means what? Audible wave means the human being's audible capacity. Okay, so over here everybody is using the word, it is from 20 hertz to 20 kilohertz. This is the normal human being's audible range. Obviously when you are older, you will not be able to hear lower frequencies or higher frequencies properly. Then you do have other modes by which you can improve upon them. Okay, now what all things produce this sound? Okay, these sound waves are produced basically by the vibrating bodies. Even when I'm talking over here, what is happening? Due to the vocal cords, a human being can speak. Even same with the animals also, even they do bark. Okay, or we can say any musical instruments, like take a flute or clarinet or any other instrument, or even a membrane, stretch membrane, like which is there in the guitar or the violin, or even a stretch membranes what you observed on the drums. Okay, take a normal tabla or pakhwas, any musical instruments, you do have a stretch membrane on that. So whenever you play that instrument, you are going to produce the sound. Okay, this is the audible range. So in this range you will be able to enjoy the sound properly. Next is the infrasonic. Next classification of sound wave is infrasonic waves. So either I can say here audible wave or a sound wave, even that will do. Okay, now infrasonic means what? Infrasonic means the frequency lower than this limit. So I should say less than 20 hertz. Less than 20 hertz is the infrasonic frequency range. Now this frequency, okay, are produced by what? The large vibrating bodies. So vibration generated during earthquake or the vibration of pendulum. Okay, and this value, these frequencies will not be able to human being to hear clearly. So human being's range is 20 hertz, 20 hertz and above, not below. So this is not suited for human being, but uh, so obviously this is specific range, I should say. Okay, then comes exactly opposite, which is ultrasonic. Now what do you mean by ultrasonic? Ultrasonic wave, this is the frequency higher than 20 kilohertz. So greater than 20k is my ultrasonic wave. So obviously human will not be able to recognize that, because 20 hertz to 20 hertz, less than is infra, higher than is ultra. Okay, but human beings can't hear, but animals like dogs, birds and bats are capable or are sensitive to these waves. Okay, now as far as this audible sound is concerned, here there are two types. Now I'll come back to, because this we can't hear, so we can't talk more about that, so we'll come back to audible sound. So in this you have basically two groups. One is musical sound and second is the noise. So obviously musical sound will be pleasing, everybody will like to hear. Okay, suppose I draw a waveform like this, okay, which is a normal continuous uniform waveform I drew here. Okay, so sound produced basically by the tuning fork, or I should say a flute or a piano, exactly will be in this range. Okay, so a typical waveform I showed it over here. Now to show noise, it's not a difficult job. I had to just show a jittery waveform, which is just not continuous. Anywhere it will be like going up or going down without any much uniformity. So what is this? This is basically unpleasant, discontinuous and non-uniform sound produced by the irregular succession of disturbance will be called as the noise. Even we say the unwanted sound is basically noise. So where do you get this sound? Depending on the explosion of cracker or the sounds what we get in factories, a sound produced by the vehicle. If some driver is driving his vehicle at a very high speed with lot of honking, definitely that will come under this. Okay, then we'll have some definitions. The first definition I'll see is sound intensity. Okay, so sound intensity, when I say so, what is sound intensity? The amount of sound energy crossing per unit area around a point in 1 second is known as intensity of sound. What is the formula for intensity of sound? I'll say I is equal to 2 pi square rho c n square a square. Now what is over here n? N is the frequency. Okay, what is rho? Rho is the density. Okay, then what is a? A is the amplitude. Okay, and what is c? C is the velocity of the wave. Fine. So over here we can say that the other definition, we can say that intensity is nothing but power transmitted per unit area. So if at all I use this definition, okay, then I can say the unit of intensity is watts per meter square, because power unit will be watts and area will be in meter square. Okay, so the intensity of the faintest sound, faintest sound, okay, which can be heard is about 10 to the power minus 12 watts per meter square. Okay, so this is a specific value which will come back to it again later also. So over here what we can see that this value will come again when we'll define the intensity level. So suppose I want to say that the intensity level, okay, intensity level formula is basically given by 10 log of I by I0. Fine. So now what I said, this value 10 to the power minus 12, this is also called as I0. Okay. So the unit of this intensity level, okay, intensity level is dB. Intensity is watts per meter square, but intensity level, the unit is dB. Okay. Now suppose I see this intensity value 10 log, suppose this I is given as 10 to the power minus 12 itself, again same. Okay. So what will I say? This is I0 is also 10 to the power minus 12, which is standard. This will not change again. Okay. So what will happen? I'll say 10 log to the base 10. This I at this point of time 10 to the power minus 12 divided by 10 to the power minus 12, okay, gets cancelled. Okay. And I get what is called as 0 dB. Okay. The intensity level of the least audible sound. What I'm saying? Intensity level of the least audible sound is 0 dB. Correct? But if I change the value of this I by a little amount, suppose I say that the value of I is intensity level I am finding. So the intensity level formula I said 10 log to the base 10 I by I0. Okay. Now suppose I is 1 watt per meter square and I0 is fixed 10 to the power minus 12 watts per meter square. Substitute the values over here. So I get 10 log to the base 10 of 1 divided by 10 to the power minus 12. Okay. What will I write then? I'll write 10 log, okay, this 10 to the power 12 will go up and you get 10 to the power 12. So this will give me 10 into 12 log 10 to the base 10. So you get 120 into 1. So 120 dB. So I is only this much. I got the value of 120 dB. And here my I was same 10 to the power minus 12. And I got the least audible sound intensity level to be 0 dB. Okay. We'll take one more problem. Okay. Where if we use the value of I to be 10 to the power minus 8, okay, watts per meter square, then what is my intensity level? Intensity level is 10 log to the base 10 to the power minus 8 by 10 to the power minus 12, because this will not change anytime. Okay. So this will give me 10 log to the base 10 to the power minus 8 plus 12. Fine. So this will give me 10 log 10 to the power 4. Okay. So this will give me 10 into 4 into log 10 to the base 10, that is 40 dB. So this is the way we can solve many such problems. Okay. Because the value of I will change. Now this is the value of I, which is the sound or the intensity for the radio at home. Okay. So the values keep changing. Okay. As depending on the sound. Now there is one more unit I had to introduce over here, that is called as bell. B-E-L. This is also written as or B-E-L. So what I can say, that 1 bell is equal to 10 dB. Okay. So if I say over here is 120 dB, means this is actually 12 bells. Okay. This is 40 dB. So what should I say? This is 4 bell. So this is the way we can introduce this definition here. So what is 1 bell basically? I can define this. So 1 bell is defined as the relative intensity between the two sound notes if one is 10 times more intense than the other. Okay, so intensity level in bell is given by 10 log to the base 10 I by I0. Relative intensity, so defined as relative intensity between two sound notes if one is 10 times more intense than the other. Fine. So this is what is the understanding as far as intensity, sound intensity or intensity level is concerned. Okay. Then we will define the next definition is loudness. Loud, you say loud. How loud? That's what I have to answer over here. So we can say over here that the characteristic of a musical sound means this, okay, which is, what is the characteristic of the musical sound? Musical sound is continuous, pleasant and uniform. Okay, so the characteristic of musical sound by which a loud sound can be distinguished from a faint sound even if two have the same pitch is called as loudness. Okay, so this is the basic definition. You need to distinguish properly loud sound and the faint sound. So here I'll write loud sound and faint sound. If you distinguish, even if they have the same pitch, means this is the loudness. And the unit of the phon, basically PHON, phon is a unit of loudness level. Unit of loudness level. Okay, and basically a phon is a unit used to describe this loudness level of a given sound. So what we can say, 0 phons at 1 kilohertz frequency is set at 0 dB. Okay, 0 phons at 1 kilohertz is set to be 0 dB. So depend on how the values of dB increases, okay, this value also will increase correspondingly. That's what is the understanding as far as loudness is concerned. Now the third definition which we want to discuss over here is the pitch. Now what is this pitch? Means pitch is basically, suppose I say the diagram, I'll say lower pitch and higher pitch. Suppose I draw a waveform like this, and second waveform will be little more closer. Okay, suppose I draw it this way. Okay, so here I say this is lower pitch and this is higher pitch. So what we can say over here, that pitch is basically a characteristic of a musical sound by which one can distinguish between a shrill sound, SHRILL, shrill sound, from a hoarse, HOARSE, grave or hoarse sound, even though the two sounds may be of same intensity. Okay, so you should be able to distinguish between a shrill sound and a hoarse sound even if they have the same intensity. Like here we said, just now we have defined loudness, distinguish between loud sound and the faint sound. Okay, here we are trying to distinguish between the shrill sound and the hoarse sound. Okay, so pitch basically depends on frequency, but it does not depend on the loudness. Okay, so what is the example now? Usually the small kids or ladies usually have the shrill sound of because of the higher pitch, and the voice usually of an old person, he will not talk very loudly or faster, so we can say that the person is speaking, old man is hoarse because of the lower pitch. This is the way we can distinguish between. Okay, then if at all I have to take the fourth definition also, so I can see it is quality or timbre. Now what is this basically? This is basically characteristic of a musical sound which enables us to distinguish between the sounds produced by two different musical instruments or two different persons, although their pitch and loudness may be same. Okay, which means what? Suppose I have a tuning fork. Okay, the sound produced by a tuning fork, suppose it is like this. Okay, suppose then I play a flute, or a person is singing, or some person is playing a violin. Okay, so all that different waveforms will give you the idea as far as how the timbre appears. So timbre basically, again I repeat, is the characteristic of a musical sound which enables us to distinguish between the sounds produced by either different instruments or a different person. Okay, even though their pitch and loudness be the same. Okay, then comes what is called as the audibility. Now what is audibility? Audibility is the limit. Limits of audibility depend on intensity and the frequency of sound. So in order to hear sound, it must have minimum intensity and frequency. Then we say that something is audible. Okay. Now we have two important definition called as threshold of audibility and threshold of feeling. Very important definition we will cover. So over here, this is what threshold of audibility means: smallest audible intensity for a given frequency. Smallest audible intensity for a given frequency is called threshold of audibility. So threshold of audibility, we already used one example. What we said, that the value of I0 10 to the power minus 12 watts per meter square at 1 kilohertz is basically 0 dB. Okay, we showed this with the example. This is 0 dB. Faintest sound 10 to the power minus 12, which will give me my threshold of audibility. Now I had to talk about the threshold of feeling. Now what is threshold of feeling? The maximum audible intensity without painful sensation is called threshold of feeling. So this is my upper pitch limit of audibility, and this is the lower pitch limit of the audibility. Now we can just show a audibility curve also. Here I'll show the curve and then we will stop. So suppose here I show the audibility curve. So for that I'll have to take x-axis and y-axis. So on x-axis I have the sound level in dB. Okay, suppose I begin from 0. So 0 20, 40, 60, 80, 100, 120, 140. This is dB. Okay, so 20, 40, 60, 80, 100, 120, 140. Okay, as far as frequency is concerned, on my x-axis I will say 20 hertz, 50 hertz, then 100, then 200, then 500, then 1K, 2K, then 1K, 2K, 5K, 10K and 20K. So I covered the full audible range, 20 hertz to 20 kilohertz. Okay, so over here usually the graph is from here. Okay, so you come back to around 1 kilohertz like this till 1K. Okay, and then it starts rising again. This is usually the graph. Okay, this is minimum audibility curve. Minimum audibility curve. Okay, then higher I'll show about the threshold of feeling. What we said, highest frequency, maximum audible intensity. So maximum 120 is okay, but 120 is the way we can show over here. Okay, so here I can show this is my threshold of feeling. Usually this is little straight, okay, but some pitch can be there. So maximum part is over here. So this is the auditory response. This area is the response, we can say, inside. So this is minimum, this is maximum. So I can say threshold of audibility, smaller audible intensity, and this is highest maximum audible intensity. So this is my usually the audiogram is concerned. Okay, so this is the minimum audibility curve, and this is for the, so one can say around 1 kilohertz. Okay, we are trying to be get little lower value of sound in dB is concerned. Okay, and again then it speaks as the frequency rises. That's what it shows. Okay, so the peak sensitiveness of the ear will range from 2 kilohertz to around 2.5 kilohertz, and beyond this the ear is little more insensitive. Okay, so that's what is the as far as why audiogram is concerned. Okay, so in the next lecture we'll talk about the reverberation time and the formula. Okay, thank you very much.